Imagine a train so fast that it covers 30 kilometers from airport to city in just 7 minutes, reaching a breathtaking 431 kilometers per hour. That's the Shanghai Maglev, the fastest train on Earth. You're watching Mega Constructs, where we explore colossal builds from around the globe. Let's start today's journey. Imagine you have just landed at one of the busiest airports in the world. You're tired, your luggage is heavy, and you still need to get to the city center, which is 30 kilometers away. A taxi will take at least an hour, maybe longer if there is traffic. The subway is cheaper, but it also takes nearly an hour and involves multiple connections. Now, imagine there is another option. A train that floats above its tracks. A train that takes just 7 minutes to cover the entire distance. A train that reaches speeds of 431 kilometers per hour, faster than an F1 car and almost as fast as a small aeroplane on its takeoff run. That train is the Shanghai Maglev, and for over 20 years, it has held the title of the fastest commercial train in the world. But here is the surprising part. The Shanghai Maglev was never really supposed to make money. It was built as a demonstration, a proof of concept to show the world that China was ready to leapfrog conventional rail technology. Since it opened in 2004, the line has operated at a financial loss almost every single year. Yet, the trains keep running, the passengers keep riding, and the record remains unbroken. Today, we are going to find out why. We will explore the science of magnetic levitation, the politics behind the project, the staggering engineering that went into building it, and what the future holds for the world's fastest train. The problem Pudong International Airport created. To understand why the Maglev was built, we need to rewind to the 1990s. Shanghai was growing at an incredible rate, but its only international airport, Hongqiao, was located west of the city center and was quickly running out of space. So, the government decided to build a brand new airport on the eastern edge of the city, near the coast. The new Pudong International Airport opened in 1999 and was designed to handle millions of passengers. But there was a problem. Pudong was located roughly 30 kilometers from the existing city center. To get there, travelers had to take a slow subway line or sit in traffic on a congested highway. A direct connection was badly needed, but a conventional subway would still take nearly an hour. Something faster was required. China's leaders saw this as a perfect opportunity to test a futuristic technology, magnetic levitation. A maglev train would not only solve the airport connection problem but also serve as a powerful symbol of China's technological ambition. In 2000, the Chinese government signed a contract with a German consortium led by Siemens and ThyssenKrupp to build the world's first commercial high-speed maglev line. The route was simple. Connect Pudong International Airport to Longyang Road Station in the eastern suburbs, where passengers could transfer to the city's metro network. Construction began in March 2001, and the timeline was aggressive, just 3 years from groundbreaking to opening day. The total length of the line is 30 kilometers, and it cost roughly $1.2 billion to build, which at the time was a huge sum for a demonstration project. Adjusted for inflation, that would be over $2 billion today. The average cost per kilometer was around $40 million, far more expensive than conventional high-speed rail, but the goal was never really to be cheap. It was to prove that maglev technology worked at commercial scale. The line finally opened to the public in January 2004, and it instantly became a sensation. Tourists from around the world flocked to Shanghai just to ride the flying train. The secret of levitation: how magnets float a train. So, how does a maglev train actually work? The word maglev is short for magnetic levitation. Instead of using wheels, the train floats above the track using powerful magnets. By eliminating contact between the train and the rails, there is no friction to slow it down, which allows it to reach much higher speeds than a conventional train. The Shanghai Maglev uses a system called electromagnetic suspension, or EMS. This is the same technology developed by the German company Transrapid, which was the pioneer in high-speed maglev design. Here is how it works in simple terms. The train wraps around a steel rail, like a claw gripping a bar. Electromagnets on the underside of the train are energized, creating a magnetic field that pulls the train upward toward the rail. This attraction lifts the train about 1 centimeter off the track. Sensors on board constantly adjust the power of the magnets to maintain a consistent gap. If the gap gets too large, the magnets pull harder. If it gets too small, they ease off. This happens thousands of times per second. For propulsion, The maglev uses a linear motor. In a conventional train, the motor rotates wheels to push the train forward. In a maglev, the motor is stretched out along the track. Electromagnets in the track create a moving magnetic field that pulls the train along, without any moving parts. Because there is no physical contact, there is no rolling resistance. The only thing limiting the train speed is air resistance, which is why the streamlined nose is so important. The ride is incredibly smooth. Without wheels bouncing over rail joints, the train glides almost silently. Passengers often say they cannot even tell when the train has started moving. The only sign that they are accelerating is the scenery rushing past the windows, and the immense G-forces pushing them back into their seats when the train hits top speed. The staggering speed. Now, let's talk about the headline figure, the speed. In regular commercial service, the Shanghai Maglev reaches a top speed of 431 km per hour, or 268 miles per hour. The entire 30-kilometer journey takes just 7 minutes and 20 seconds. By comparison, a taxi during moderate traffic takes 45 to 60 minutes, and the subway takes about 50 minutes. During testing, the train achieved a maximum speed of 501 km per hour, 311 miles per hour, in 2003. That remains the fastest speed ever recorded for a conventional maglev train on a commercial track. The Shanghai Maglev is, without question, the fastest train in regular passenger service on the planet. To put that into perspective, a Formula One car can reach speeds of around 370 km per hour on a straight track. The Maglev is 60 km per hour faster. A Boeing 737 on its takeoff run reaches about 280 km per hour. The Maglev is 150 km per hour faster. Japan's famous Shinkansen bullet trains typically run at 320 km per hour. The Maglev is 100 km per hour faster. And the Eurostar train through the Channel Tunnel tops out at 300 km per hour. The Maglev leaves it in the dust. The ticket price. If you want to ride the Shanghai Maglev yourself, here is what you need to know. A single one-way ticket currently costs 50 yuan, about $7. If you are traveling with a group of 10 or more, you can get a 10% discount, reducing the price to 45 yuan per person. There is also a round-trip option, but prices vary depending on the season. For comparison, a taxi from Pudong Airport to the city center will cost around 150 to 200 yuan, depending on traffic. So the Maglev is actually quite reasonably priced, especially considering the speed and the unique experience. Trains typically run from 6:45 in the morning until 9:40 at night, with departures every 15 to 20 minutes during peak hours. The station at Longyang Road is integrated with the Shanghai Metro, so you can easily transfer to other parts of the city. The airport station is located directly inside Pudong International Airport's terminal building, making it extremely convenient for arriving passengers. If you ever visit Shanghai, riding the Maglev is a must-do experience. It is not just transportation. It is a glimpse into the future of travel. A global race. How China compares. The Shanghai Maglev holds the world record for the fastest commercial train, but it is not the only Maglev project in the world. Japan is building its own Maglev line, called the Chuo Shinkansen, which will connect Tokyo, Nagoya, and Osaka. The Japanese system uses electrodynamic suspension, EDS, a different technology that relies on superconducting magnets and can achieve even higher speeds. In 2015, a Japanese test train reached 603 km per hour, over 100 km per hour faster than China's Maglev. However, Japan's project has faced massive delays and cost overruns. The construction cost has ballooned from an initial estimate of 7 trillion yen to over 11 trillion yen, roughly $70 billion, and the opening date has been pushed back from 2027 to the late 2030s. The line is still not fully approved, and some sections have yet to break ground. Germany, where the Transrapid technology was invented, has never built a commercial high-speed Maglev line. The only other operating Maglev systems in the world are low-speed urban lines, such as the one in Changsha, China, which runs at just 100 km per hour, and a few airport people movers in places like Japan and South Korea. This means that China is currently the only country in the world operating a high-speed Maglev in commercial service. And they are not stopping there. The future, China's 600 km per hour Maglev. In 2021, the The state-owned rolling stock company CRRC unveiled a prototype of a new maglev train designed to run at 600 km per hour, 373 miles per hour. The train, officially named the CRRC 600, is a 5-car set that can be expanded to up to 10 cars. It uses superconducting electrodynamic suspension, EDS, the same technology as Japan's maglev, which allows for a larger gap between the train and the track and potentially even higher speeds. In testing, the CRRC 600 has already demonstrated stable operation, and the company claims it will enter commercial service sometime around 2030. The train will be used on dedicated maglev lines connecting major Chinese cities, including Beijing, Shanghai, Guangzhou, and Wuhan. The impact would be enormous. A maglev running at 600 km per hour would slash the travel time between Beijing and Shanghai from the current 5.5 hours to just 2.5 hours, faster than a plane when you factor in airport security and transfers. This could seriously challenge domestic air travel on high-density routes. CRRC has already built a 5-kilometer test track in Qingdao to validate the technology, and they are planning a longer demonstration line. The goal is to have a commercial network of nearly 4,000 kilometers of maglev lines across China by around 2035. Beyond maglev, the Hyperloop alternative. And China is not stopping at maglev. State-owned researchers are also working on a Hyperloop system, a concept originally popularized by Elon Musk, in which pods travel through low-pressure tubes at extremely high speeds. In 2024, Chinese engineers announced that a Hyperloop prototype had reached 623 km per hour, 387 miles per hour during testing, faster than the maglev. The ultimate goal is to achieve 1,000 km per hour, 621 miles per hour in commercial operation, which would cut the Beijing-Shanghai travel time to under 2 hours. But Hyperloop technology is still in the early stages, and many experts remain skeptical about its feasibility on a large scale. Maglev, by contrast, is a proven technology that is already in commercial service. The Shanghai Maglev has been operating safely for over 2 decades, and the CRRC 600 is expected to follow. For the foreseeable future, maglev is likely to remain China's primary next-generation rail technology. The verdict: was it worth it? So, after 20 years and billions in losses, was the Shanghai Maglev worth building? From a purely financial perspective, no. The line has never turned a profit, and it probably never will. But the maglev was never intended to be a business. It was intended to be a statement. The message was clear. China is not just a manufacturer of cheap goods. China is a nation of innovators, capable of building the most advanced infrastructure on the planet. The maglev put Shanghai on the map as a global technology hub and inspired a generation of Chinese engineers to push the boundaries of what is possible. Today, that initial investment has paid off in ways that are hard to quantify. The expertise gained from the Shanghai Maglev directly contributed to China's high-speed rail revolution. The country now operates the largest high-speed rail network in the world, with over 45,000 kilometers of track. And Chinese engineers are now leading the development of the next generation of maglev trains, which will be even faster and more efficient. The Shanghai Maglev was not just a train. It was a launch pad. So, the next time you watch a video of China's new 600 km per hour maglev or read about the Hyperloop, remember, it all started with a 30-kilometer demonstration line from Pudong Airport to the suburbs of Shanghai. A train that floats. A train that flies. Conclusion: the fastest train on Earth. The Shanghai Maglev remains the fastest commercial train on Earth, a title it has held for over 2 decades. It is a monument to engineering ambition, a financial failure, and a technological triumph, all at the same time. For millions of passengers, it has been the thrill of a lifetime. For Chinese engineers, it was a crucial step toward the future. If you ever find yourself in Shanghai, do not miss the chance to ride it. Stand at the window, feel the acceleration push you back, and watch the city blur past at 431 kilometers per hour. That is the story of the world's fastest train. Thank you for watching Mega Constructs. If you enjoyed this deep dive into magnetic levitation, please like, subscribe, and hit the bell. Would you ride a maglev train? Or does the idea of floating above the track at 400 kilometers per hour make you nervous? Let me know in the comments below. I will see you in the next video.